Thank you, Gerardo. Thank you, Manuel. Welcome to this meeting. We are going to present to you the demo that we were presenting on the demo on the EuCNC. That is a demo with all the different SDGs that belongs to ETSI, showing you a use case regarding with the deployment of a private 5G network. In this case, two applications: the 5G core network and the 5G RAN, using all the different groups that you can see in the screen: OpenCapif, OpenOP, OpenSlice, Open Source MANO, of course, and Teraflow SDN. The structure or the architecture of that demo is based on all the SDGs. So OSM has a central role here in the architecture, because OSM is able to manage the infrastructure that you are going to use in the deployment of the different applications. In this case, and I'm going to show you, you will see how OSM is able to manage the different sites. In this case, sites based on the OpenStack beam and the different Kubernetes clusters that we are able to create or register if the clusters already exist before in OSM to use by the different applications to deploy. In this case, the RAN application based on OpenAir interface, and the core application based as well in OpenAir interface. So, as I mentioned, OSM has a central role in this deploy scenario, and I'm going to show you how is the interaction between OSM and the different components. So OSM manages infrastructure required to deploy these two applications, the 5G core and the RAN. It manages the life cycle, that is the registration, creation, updating, and deletion of the different, in this case, Kubernetes clusters. But in the case of the Vim, you can register the Vim, update the different parameters you have. And it's just not with OpenStack. You can also register a Vim based on Azure, on GCP, on AWS. OSM has already these capabilities to register a private cloud or a public cloud. After that, you can create the connectivity between two sites. In this case, the scenario is based on two sites. One side is going to have the core cluster, and the other side is going to have the RAN cluster. Using Teraflow SDN, you are able to create a connectivity between these two sites. It's a programmable connectivity that you can create using the other component that is also loaded on OSM. So after that, you can see and you can evidence. I'm going to show you that in the second part of this presentation, that you can check the connectivity between the two sites once you already create that connectivity using OSM instructions. In this case, the instructions is based on a network function descriptor and a network service descriptor, sorry, where you define between which sites you want the connectivity, and Teraflow SDN is going to translate that request that is created in OSM to a programmable connectivity in a SDN network where is simulated using the Container Lab application here. After that, once you guarantee that connectivity between the two sites, you can use OSM to deploy the application. So in this case, OpenSlice calls OSM using the Northbound interface and the APIs that are available there. When you deploy OSM, the MBI components, it's a core on the OSM deployment, because it's going to be the component that allows you to call OSM from external calls using just HTTP requests based on API calls. So using that component, you are able to tell OSM to deploy applications on the different sites that you already registered there. You just need the site ID and the application that you want to deploy that are also loaded on OSM. So that's going to be enough to deploy the application. It's basically just 3 commands, as I'm going to show you in the presentation, in the second part of the presentation. And once you have deployed the applications on the different sites, some of the applications, in this case, the NEP, the network exposure function, through that network exposure function, you are going to expose the core functionalities via API. So with this integration, you can integrate other components of the SDGs, of the ETSI SDGs, that in this case is OpenOP and OpenCapif, to be able to be compatible with other standards like camera and the 3GPP, of course. So this is like the whole picture, and this is how different components interact with OSM, and how OSM in the other way around interacts with the components to create like the whole architecture to deploy this 5G private network, right? So for this, I'm going to show you like in practice how OSM works with all the components and how we are going to use OSM in a simple way to create all that, to create all the picture that I showed. So in this case, for the Vim registration, you have just basically the OSM installed in a management cluster, and you have the two different sites. In this case, this could be a tenant in the same OpenStack Vim, and a second tenant for the site B. So with OSM, you can register the two sites using just a couple of commands. And after that, you can see in the user interface how the sites are registered. I'm going to show you this in a couple of slides. Also, you can create or register the clusters. With OSM, we have the capability to create clusters in OpenStack using tools like Capi. So with that, you are able to create the Kubernetes cluster. If you don't have the Kubernetes cluster, OSM is in the capability to create a cluster for you and also register the cluster in OSM to be used in the future, right? But if you already have the Kubernetes cluster deployed, you can also register the cluster. That is not a problem in the OSM to be used to deploy the applications. So in this video that I'm going to pass really quick, I'm going to show you how we can create the clusters. If you don't have the clusters, you can create the clusters here. So basically, you need just like a cloud a closed YAML file that is a file defined in the OpenStack documentation with all the different credentials or the different things you need to register the Vim. We are going to use our internal laboratory here that we already have like a file defined, and we are going to register that file. So you can see how with that structure, we are going to use just a simple command. And after we create that simple command, when we execute that simple command, you are going to see how OSM start to interact with the different components that is inside the OSM deployment. That is, for example, the Capi component, the Argo workflows component, and other components that is inside OSM to create in a declarative way all the components and the manifests that you need to register that Vim inside OSM. It's very important to say here that you are not creating the Vim, you are registering the Vim that is already created. So you can see here how in that way we already, yeah.
One comment, Juan Camilo, just take your time, okay? No hurries, okay? Take your time to show perfectly the cluster, all the steps so that they are pretty clear for everyone, okay?
Yeah. Perfect. Yeah, this is just the registration. The registration is very important to see that, and this is an important feature here, that I just want to, I don't know how to choose a part of the video. I think for this, I need to escape for the full presentation and just check the slide. But yeah, I think it's fine if I do that real quick. So let me show to you here really quick how the main component when you are registering the Vim is a secret that is created here in this part. And that secret is all that you need to interact with the cluster creation component or the cluster creation functionality. Why? Because this secret is going to be used by the other component that is the cluster API to read the credentials and to have the permissions to create the two virtual machines that we are going to create, one with the control plane and the other one with the user plane, right?
Does that secret reside in the Git repository or not?
Yes, that secret is in the Git repository, but is encrypted, as you mentioned.
Yes,
here.
Can you show it? Yes, that it's encrypted because it's a really important part. Yeah.
Yes. Yeah, we are using SOPs where you define. So you can see here that we are not using like the secret in plain text in the repository. We are uploading the secret to the repository, yes, but we are using a SOPs standard to encrypt the file. So just OSM knows how to decrypt the file to have the secret for the cluster API component, right? So this is very important because yes, you can upload the secrets, but OSM is going to manage all the encryption for you, right? So if any user has access to the source of truth, that in this case is a Git repository, as you expect that happen, the user is not going to know what the secret, what is the content of the secret if the user doesn't have like the private key. Just OSM have the private key, and this is an important part, and this is an important deployment of development, sorry, of the in the OSM cluster creation functionality. Right. Thank you, Gerardo, for the comment. So once you have that secret, you are going to see how I'm going to just to go in the video a couple of seconds. You're going to see how you can see in the traditional way how the beam is registered and how OSM already detect that the operational status of that beam is done, is okay. So that beam is going to be able to receive any request to create the clusters. So to create the clusters, it's important to have or you have to know the components that you need on the beam to create the cluster. For example, in this case, this is the command that we are going to use to create a cluster, and you're going to see how we need previously defined like a network that it's going to be used by the cluster between the communications of the control plane and the worker nodes. And you can see here, we are going to execute the command because it's taking something like 5 minutes to synchronize like the repo or the status of the repo with the infrastructure. I'm going to show you how here we have all the components previously created in the Vim that we have. That is the network. You can see how we already have external network to keep the communication between the two different planes that I already mentioned. An SSH key, if you need to access the virtual machines, and you have to do something there. And also we have a flavor that we need to deploy those virtual machines using OSM. So with those three things, you are able to create, this is all that you need, just a command and those three things to deploy the Kubernetes cluster. Obviously, you can customize the DNS configuration, and there are another custom configurations that you can use for the creation of the cluster. You can see that on the documentation. For example, the control plane node count or another, that kind of things. When you are playing with the Kubernetes cluster creation, you can modify or customize those parameters. And yeah, that's like the idea. This is all that you need to create a cluster. So once you create that, this is using a declarative way. So this is going to create a couple of elements or a couple of components and files in the source of truth. In this case, it's a Git repository that I already showed to you. So I'm going to show you how this create a new commit on the branch. And this commit has all the different customizations and all the different manifests that you need to deploy that Kubernetes cluster. So you can do that by yourself, and you can check all the different components because there are a lot of them. And after that, OSM is going to synchronize using the FluxID component, the status of that repository in the target infrastructure. So in this way, you can see how the Kubernetes cluster is being created here. And it's just a couple of, I think, it's just a matter of 5 minutes or maybe 6 minutes until you have deployed the complete cluster in an OK operational status. Here you can see how OSM already deployed the control plane, and in that moment, OSM is waiting for the status of the control plane. I mean, the different components of the Kubernetes cluster, like the kube API server, the etcd, and all the different components there, to be in an OK status. So OSM is going to tell you like, hey, the cluster is ready, and just use it. Just use it for deploying the different applications. Here we are showing to you how you can check the status in three different ways. The first one is the logs of the LCM component. And the LCM component is going to tell you what is happening in the background, what is happening in OSM in the background, what OSM is doing, and all that is in a status that where you can check using the logs what's happening and what is the status of the deploy that you request of that Kubernetes cluster. In the second part, you can see here how the customizations are what is the status of those synchronizations, that is just a FluxID nomenclature, and how this status is going to pass from false to true during the time, just waiting for Flux to do basically all that work. In this part, you can see the workflows that we are executing just to guarantee that declarative way. You can see always that the workflows is creating different components and elements in the Git repository. That's why the last step is always a Git commit merge and push. And in the last part, you can see how the different secrets are created, so you can check like all the components, or you can just validate that the components are in a okay status. In that moment, the worker node was already created, so it's just OSM is just waiting for the component to be ready. And after that, you can check also by yourself using the kubeconfig secret. You can just decode the secret and put that on the management cluster, as you're going to see there. Once you have that secret, you can check the status of the pods. That's the next step that I'm going to do here. Sorry. And you are going to see how the pods are ready. There you go. So all the pods are running, and the LCM is going to detect that the pods are running, and the health of the Kubernetes cluster is okay, is successfully deployed. So now you can just wait, because the Fluxity component here in the customization part is going to wait just for all to be true, and after that, once all is true, LCM is going to upload the status. And if you click on and if you do an OSM cluster list, you are going to see that the cluster is ready, it's idle, and is able to deploy any application that you want. This is an important functionality of this release. It's a nice functionality to have, because if you don't have any Kubernetes cluster, or if you don't know how to deploy that, OSM is able to do that for you. Right. Let me continue with the presentation here. In case that you have the clusters already created on the Beam, OSM is able to be used, just registering the cluster that already exists. So for this, this is something that we already present on the demo. You can just, using the different different kube configs that you have for those clusters, you can use just this command of OSM to be able to register the clusters. The clusters in this moment, the clusters is associated with one of the beams, but we are going to include a functionality to see it, to define that a cluster also that a beam can have multiple clusters, right? In this moment, the relation is 1-to-1, but this is going to be improved in the future. So you can register the clusters if already exist. I'm going to keep the video here, like showing to you how the registration process is also doing the same declarative, is also in the same declarative way, where you create different components and manifests on the source of truth, in this case, the Git repository, and you can see the different elements that are created and how OSM is just waiting for those elements to be ready to tell to you that you already have the cluster, and you can use that cluster to deploy any application. So you can see here how OSM is waiting for the registration of the cluster one. Once you have that registration of the cluster one, OSM is going to tell you that is done. What happened in the background? In the background, OSM is installing like all the Fluxity components in the cluster. So it's waiting just for those elements in those clusters to be ready, and it's going to check that status and that health status for you. So the same thing for the cluster B. You also have the possibility to upload or to register the cluster using the user interface. You don't need always to use the CLI. You can use also the user interface for that. So in the same way, it's going to create like the cluster B. In this case, it's going to register that cluster B that already exists on the Beam before you start this process. And I think that's it. Once you have those clusters ready, you are able to use them to deploy any application, right? So you can see here how the commit and the push is happening. And after that, the state is green. In this case, it's ready, and it's ready to be used for any application. Perfect. Right. So yeah, this is how you can, in the picture, if you remember the picture, this is the part of how you can manage the infrastructure, right? So we are going to pass to the second part of the steps. Now that we have the site A and the site B, we should guarantee the connectivity between them, because the RAN is going to be registered on the core cluster, right, on the 5G core. So for that, we are using the Teraflow SDN component that is already registered on OSM, and we are going to use a network service that is customized to create that connectivity between the two sites, right? So using Teraflow SDN, you can see how you can create programmable connectivity between between the both clusters. I'm going to show you here in a video. And yeah, we already have a package there. I'm going to show you the URL in a couple of slides, where we designed all those packages to create this connectivity. Sorry, to design how we are going to guarantee the connectivity using the Teraflow SDN component. You just need the name of the virtual networks that you are going to communicate. In this case, one in the site A and the other one in the site B. And after you have that, you can just deploy that network service. This is all that you need. You can just create the package on OSM. And after you create the package on OSM, you are just going to deploy that as a network service, as a traditional network service. You are going to do just an OSM NS create, and that's all that you need to create the connectivity between the two sites, right? You can see how we already have the package, the network service package here. And after that, you can just, you can check, you can validate how, if we try to ping between the two sites, it's not working, right? In that moment, before you create the connectivity, it's not working. We are pointing to the .5 because it's a configuration that is created on the let's say on that container lab application in the network that is simulated there. We are pointing to the .5 because it's a P that is assigned to the two sites, right? So once we create that, we can see that we already have the package. And once we have the package, we can do OSM NS create. After the NS create, that is just this command that you can see on the screen, using a config file, all this information is already public on the repository of the OSM packages. That probably you know good. After that, you can see how the connectivity is created on the Teraflow SDN application. There you go. So just deploy that. This is the structure. Oh, something happened here. Yeah, sorry. I think it's better to manage the video here outside the full presentation, just to be able to control that, because I click intentionally in another part and the presentation just go ahead. And here, there you go. So all this information, as I mentioned to you, is available in the OSM packages repository. You can check that repository if you need, or if you want to use this package for your purposes. And yes, the programmable connectivity is created here. You can see all the different configurations that is created on the Teraflow SDN application. And if I try a ping again, you can see how the ping is successfully, and how we can reach now from one side to the other side using this programmable connectivity, right? Let me continue the presentation here. And yep, after that, yeah, this is the first part of this demo that we were presenting on the EuCNC. That is basically just the infrastructure and the network management. And now that we already have the beam registered, the Kubernetes cluster deployed and registered, and the connectivity between the two sites, we are able to deploy the applications. As I mentioned to you, we have two applications. One is the RAN, and the other one is the 5G core, right? So for that, we already create also the packages that you need to use, or that you can use to deploy the two applications. One of them is using the MobSim, that is a simulator to create like the mobility in the RAN. That it's going to create some handover events in the RAN to check how the location management function is working, and how you can expose like an approximate location of the UE through the network exposure function to be used using OpenOP if you want to use the camera definition or the OpenCAPI if you want to use a 3GPP API definition. So we already have those packages, one for the MobSim and the other one for the 5G core. This is based on the OpenAir interface project. You can check like we already did something to the packages to be able to be used in this demo. All the packages are already public. You can see that on the OSM packages repository, and the other one this is a public repo just to expose the Helm charts. So you can use Helm commands for that, like Helm repo add, Helm repo update, etc. And also the packages have some patches because the infrastructure that we were using are exposing using different ports. So we already modified just a couple of lines to create that here in the public repository, right? After that, you can see how we can register those packages here. How we can create the packages is the same way. It's in the same way that we used before to create the programmable connectivity package. So we are just going to create. I'm going to, because it's better. Let me just escape the presentation here, and I'm going to manage the video from here. So you can see how we are going to create the package here using the same commands that we were using before for the programmable connectivity. You can see the ID, and that ID is also the same ID that you can see on the user interface. We are going to create the network service descriptor. Remember that in this case, we are using an imperative way. So we have to create first like the virtual network function or the Kubernetes network function. And after that, we have to create the network service definition to be associated with that network function that we created before. So you can use that to deploy the application. The network function is where you reference the Helm chart that we have on the public repo. And with the network service, you define all the different structure you need, all the instructions for the deployment of the application. So once you have the two packages, in this case, the BNF and the NS package, you are able to deploy the applications. In this case, we are going to show you that also you can use the user interface to register the packages. You don't need to do that in the CLI. And you can see how everything is synchronized in OSM. So it doesn't matter the way that you do this, everything is going to be synchronized, and everything is going to show you the same information, right? After you have this package created, you can deploy the application. So this video was just to show you how you can create the packages. Let me continue with the presentation here. Just a minute here, sorry. Right, perfect. And also you can, well, this is like the imperative way, but OSM in this new release, you can also use the declarative way. So in this case, we are talking about OSM Kubernetes applications. So with the OSM Kubernetes applications, you are going to have the same functionality, the same capability to deploy the different applications, but in a declarative way that you can see in the documentation, the different benefits of the use of this new structure of the packages and the new definition using the OKAs, right? In this declarative way, you are going to have just one element that is like in this case we are using two let's say two OKAs. In this case, one to create the namespace, but if you already have the namespace, you just need one OKA to deploy the application. One for the 5G core and the other one for the run. In that case, you can just, with a simple command, you can register the application to OSM, and this is this have a full of benefits, a lot of benefits. You can see that on the documentation, but just one of them is that you are going to declare the Helm chart version and values. You can have multiple applications inside the same OKA, so you can deploy like a full stack application just using the same OKA. In this case, for example, if you have a front end, back end with databases and with a full stack application that you need to deploy, you can define all that in the same OKA, and just using a couple of commands, you are going to deploy that, and you can create dependencies between those applications. Like, for example, I need just first the database before I deploy the backend service in my application. So you can define that in OSM, and OSM is going to do that, like the dependency management, let's say that dependency weighting or the dependency creation for you. Another cool thing of this is that you can have also like a independent management of the different components of this application. So you can manage your application of the database outside outside your front end application. This is not like embed Helm charts inside other like subcharts, because sometimes what happened in that scenario is that the database management of the different releases, for example, you forgot to update that because it's a subchart and you need another application to do that for you. Now, in this case, you can manage that like in an independent way. So you can use also that database to be used in another application different to the one that you already, to the original that was created. This is a new way to create applications, and this is the best way to create applications in OSM using these OKs. This is a new feature that we want to introduce. And yeah, also this is all in a declarative way. Something is happening in the source of truth. You can see all the different manifests and components that are created in the source of truth. So if you need to modify something, you can do that also with OSM. So yeah, this is 2 declarative deployment modes. You can do that also for the run for the run component. And yeah, basically what is going to happen is that you are going to create a commit, a push, and everything is going to be synchronized and in the source of truth. So the source of truth is going to have the same things that is deployed on the application on the infrastructure side. This is a full GitOps methodology that is implemented in OSM. So this is the way that you can create this. Okay, sorry, I'm just trying to escape just to handle the video here. Perfect. So you can see here how we are going to use the 2 declarative models in OSM, one with the KSUs and the other one with the OKAs. So here we already have the cluster registered on OSM. In this case, we have a cluster A and a cluster B. You can see here how this these clusters or the applications that we already created before are going to be deployed on these clusters. You can see here how we already have on the OKA packages the applications that we need, or the applications that we want to deploy. In this case, we have the OpenAir interface 5G core and URN sim. We're not going to use for this video the mob sim simulator that I mentioned before. That is another one that is based also on the OpenAir interface project that is going to deploy a RAM capability on the side B, right? So after you have deployed that, you can see in the subtitles what is happening here. And you can see that also how we are creating the OKA. We are waiting for the status of that. We are going to create also the namespace, because as I mentioned to you, if you don't have the namespace created on the cluster, OSM is going to do that for you. And yeah, so here you can see how with just a couple of commands we can create a full application using a profile type. This is all these parameters I defined in the documentation. You can see how you can use different profiles if you want to manage the application in different, like not just cloud providers, so but also in different like Kubernetes clusters, Kubernetes ecosystems. Yeah, this is a new feature that is very powerful and is introduced here in OSM. So you can see how the network service is deployed. In that case, you can see here how Flux is synchronizing this OSM, this OpenAir interface 5G core, and how the different pods are going to be created here. You can see how now OSM is synchronizing that the status that is in the source of truth with the target infrastructure, and is now deploying all the different components. In this case, is the pods of the 5G core there in the target infrastructure. Now we are going to do the same thing for the network service, for the RAN application. So the same thing here for the RAN application. So you can see how we can add the URN sim application here. This is the OKA package that we are going to use for the deployment. And after that, you can check how when we create the app is going to create the pods on the side B, right? So yeah, now that you have the OSM app list here, You can also check that on the source of truth. You can see the different commits that are created there, and you can check here how. Sorry. And you can see here how the application is deployed and everything is running. You can see also, you can check the logs between the site, between the application of the run and the code, and you can see how we already registered the UE that is simulated on the site B in the site A core. And this is just regarding with the declarative way. So let me keep the presentation here. This is just the final part. After show to you these declarative capabilities and these new features that we are introducing, this is just to close like the full picture. So now that you have that on OSM, you can deploy that using OSM, or you can use that, or you can deploy that using OpenSlice. OpenSlice is going to call the AMBI, the northbound interface of OSM, where different APIs are available there to deploy the applications on a site. You just need like the ID of the application of the network service, and sorry, of the network service package. In this case, is the instance, but you just need the network service package ID, and you just need the beam ID, and with that is going to be enough to deploy. The application is in the AMBI. It's important to mention here that everything is using simulated subscribers, but this should work in a real scenario. This is how you can use OpenSlice to deploy the application. So yeah, in this case, you have here the catalog, the networking. Well, I'm going to just let the video be played. So you can see here how you are doing, or you are using the marketplace to deploy the applications in the infrastructure, in the target infrastructure. Remember that this is using the OpenSlice user interface. So here, service order is created, and you can just wait for that to check how the application is done. The 5G core is already deployed, and the run application is already deployed. So here you can see, using this interface, how the pods are running in the two sites. One for the mob sim, that's the run part, and the other one for the 5G core site. So that's it. That's how easy it is to deploy the application using also OpenSlice. There's another way to deploy the core and the run on the target infrastructure. And oh, sorry, clicking the wrong button. And after that, the final picture and the technical details of all these scenarios is this one, where you can see the different flavors that we use, the different networks that we have, how we can, which networks we use to communicate the clusters, and all that technical details are basically on this picture, just for the OSM and the infrastructure part. Also the Teraflow SDN part is there. And I think that's a final slide. So thank you so much for all your attention here. Sorry that it takes some time to explain all this, but it's not easy to explain the different features that you we add to OSM, and how you can interact with OSM in two different ways: in the imperative way, using the traditional network function, network service deployment, and now with this new declarative way, using the OKAs application deployment. Also, the new features that we introduce of the cluster creation using the cluster API component that is also deployed when you deploy OSM, and how you can create clusters in a target beam. You don't need to create, or you don't need any knowledge in the Kubernetes creation, in the Kubernetes creation process. You just need to use OSM, a couple of commands, and that's it. Thank you so much for all the attention, and I'm here for any question if you have one.
Thank you, Juan Camilo. Is there any question? No, any question? Well, so thank you very much. Let me add something, okay? Because well, you have seen the demo. The demo is really complete from the point of view of the all SDGs, okay? It involves of all SDGs, but here I think that the role of OSM is really important. Okay, we have a relevant role in the demo because, well, we are say in the center of the creation of the infrastructure, and also we are, because it's basically created by us, also the connectivity through TFS, but the creation in the cloud is basically done by us, and also the role of OSM for the deployment of the applications. And here, what is important is something that also Juan Camilo commented, is that we are using in the demo the imperative framework, but it's clear that the next step to move forward with this is to use the declarative framework at that open slice, and is using that directly. Okay, that would be our main intention. Okay, in the next for the next demos. Okay. Well, what else? I think that well, I think that that's yeah, I was about to mention something else, that the demo and this kind of exercises is also allowing us to work on sorry, to be able to fix some of the technical gap that we had. For instance, the cluster API or the clusters we created with cluster API were in principle working well. However, we found that there were issues with that and it was not working as expected. So there were a lot of things that were fixed by Juan Camilo and Alejandro to be able to achieve that. So let me also congratulate you for a great work. Okay.
Thank you, Gerardo.